Hey guys, it's Luke with Austin's Appliance Service again. I hated that video so much, I didn't want that to be the video that I left on there. If you haven't noticed, I hate cameras. It comes out when I have to try to talk in front of a camera. I absolutely hate cameras. It clams me up, and so I'm going to try really hard to fight through that because I'm not actually a shy person or a clammed up person. But it drives me, I don't know. Cameras, I hate them. I've always hated them. They drive me nuts and they shut me up. So, I'm going to try to fight through that. I absolutely hated that last video because I was like listening to some dry lecture. You know, it reminded me of my science teacher in school that would put everybody to sleep. So, anyway, I'm going to try to redo it actually because it was just terrible. I hated it. I hated that video. I'm not dry and boring. I think you guys probably know that by what the things I write. I'm not typically a dry, boring person, but like I say, the cameras typically make me clam up, so I'm going to try to fight through that. I'm going to try to redo this video because, like I said, that one was so awful, so boring, dry as toast, and so I want to redo it. I want to try to make something that's, you know, informative, but not put you to sleep, because that's not typically who I am. So, I'm going to try to redo this, and I think I'm going to try to leave it on this front perspective, because I can't get enough distance to try to show you guys the things I'd like to show you. You know, last time in the video, you guys could only see about that much of the meter. So, I'm going to try to operate from the front. This might be a little awkward, but I'm going to just, again, I hated that video so much. It did not go well. So, what we got here is our voltmeter. And now I can see better what you're seeing. So, amperage, DC. That's that straight line. That means it's DC voltage. Amperage AC. Alternating current. That's most what you're going to have in your house. If you were to, your outlets in your house, you know, most everything that you're dealing with is AC. DC is typically batteries, battery in your car, things like that. We already kind of went over that, but DC, we talked about the difference in the sine waves. Now, the looping hills there is the alternating current. The straight line is DC. And we talked about how that's why you don't find a lot of high voltage DC application, because DC is always present. Therefore, if you get your hands on high voltage DC, you cannot let go. And that is the reason that you don't typically see high voltage DC application. I see it on the internals of some things. They're making inverted, variable speed compressors. They're using an inverter to turn our AC voltage into DC. I see it also in some washer motors. They're using high voltage DC in some application, and it's pretty much test everything by what's called resistance, because if you try to test by voltage and happen to get shot, you're in big trouble. So that's why you don't typically find DC voltage in your house, but there is internal components in some appliances that I'm working on that has that DC voltage. But again, you guys will probably never deal with it. It's nothing that I would ever recommend that you try to tackle yourself. When you're talking about minor repair, things like that, you know, go for it. But when you're getting into things that are over your head, getting into things that are, you know, particularly if you know that, or if if you're unsure, of course, don't do it. But if you've heard that it uses DC voltage, don't get in it, because quite honestly, that's dangerous. We talked about the difference between the 50 hertz and 60 hertz, the distance in that sine wave. And so, again, DC voltage, and this is alternating or AC voltage. It's that alternating current. There's a wave that's there and gone. It's just, it happens so fast, unless you have a very high dollar meter, you'd never see that sine wave. But that's the difference, DC voltage, AC voltage. You know, and that's essentially what you got here on your meter. When you see that wavy line, that's AC. When you see a straight line, it's DC. And that's amperage, uses the clamp. Anytime something is drawing electrical, it's drawing amperage. The more it's drawing, the higher the amperage draw. And there's an expected amperage draw with certain components. You know, if I'm looking at a bake element on an oven, I'm typically looking for somewhere between 12 and 15 amps. That's another way we check. That's how I check magnetrons on microwaves. Microwaves, and I know I've wrote on it before, but microwaves are very dangerous to work on yourself. And I do not check them by voltage if I'm trying to check them while they're running, because you have a high voltage transformer in there that's producing hundreds of volts, way more than my voltmeter is capable of being safe in using. These leads are rated like 600 volts, and that would far exceed that. So when we check a microwave, typically we check it with the amp clamp. And what you're looking for is, what is it drawing under a load? If it is drawing the proper amount and still not heating, it's not working. What else do we got here? Again, this is capacitance, which not typically something you're going to use. This is our ohms. This is that path we were talking about. Now you can check resistance based on, with this setting here, you can check the resistance based on the wire schematic. But, you know, most of the time, that's probably something you want to leave to me. The best function that you could use here is there is typically on all of these that have this test for continuity, there is a setting that is essentially just an alarm setting. Some might call it a beeper setting. But when I do this, and all that's telling me is essentially there is a path. So you imagine there's something between here, a wire between here. You know, we did it earlier, but, you know, this piece of wire from here to here, we have a path. Now, really good for checking anything without power. This is a great way of checking things. Fuses, thermostats, elements, switches, anything that has to have a connection from point A to point B, and it's no longer present, this is going to tell you. You know, if I've got a bad element, no beep. If I've got a bad fuse, no beep. And so that is one of probably the best functions and safest functions for someone to use in their home, is that continuity sense. It's got that little, again, almost like an omega, Greek omega, and if you're a video game nerd, you know, the Kratos symbol, not the Zeus symbol up here. Anyways, I just gave myself away. So that's continuity. Now, again, we talked about hertz. You're not going to usually, hertz is something that's very technical, something that someone that's just looking to fix their own stuff is really not going to use. Some of these components, like capacitance with nanofarads, when you're checking if the capacitor still has the capacitance value, or hertz. I mean, these are things that guys that are working electronics, guys that are doing electronic repair down to the component level. That's, you know, these are the kind of guys that are going to use that stuff. You're not typically, I don't really use it. I mean, there are some scenarios where I can check a capacitor, but typically I already know by the way. So a capacitor a lot of times is used to help, let's say, a motor and a washer. But I'll know the capacitor is not functioning by the motor itself, the way it's acting. If it's really laboring to go, it's because the capacitor is no good. So hertz, again, it's just not one of the things you're going to use. We got Celsius and Fahrenheit up here, and there's a jack that comes with the meter that you would plug in here, and then you could put that into, you know, your oven, your dryer, whatever it is you're checking. Again, this here, I honestly don't even know what it does. And I've been doing this 20 years, and I don't know. It looks like it calls down Zeus, as far as I can tell. So I don't know what that one is for. I'd have to do a little look, and I see an AC symbol, and I see NCV. No. So there you go. So that is just some functions on the meter. And again, I just wanted to do a different video. That last video, dry as toast. And I'm not that kind of person. But what happened, I hate cameras. I absolutely hate cameras. And so they clam me up. I hate them. So I thought I'd gonna go a little more casual, a little more loosey-goosey. Didn't even bother to change into my work shirt. And if you're curious, yes, I'm wearing my pajama pants. This is my Saturday attire. So, you know, I wanted to approach this a little different. Those dry as toast videos, it's just not who I am. But again, I hate cameras. So that's something I got to get past. So just, now I don't know if I can do it. This is, we'll try to, no, that's not going to happen. Let's just flip it around. For this one part here, we're going to have to switch the perspective. You know, just a quick example of, we'll just do voltage. So here's my voltage. Now I want to go I want to change this straight line to AC, because what I'm dealing with in my house is AC. Then I just go from here to here, and I've got 120 volts. And that's, you see the decimal point, so it, and that'll change if you're dealing with in resistance. You might be dealing with thousands. It'd be a K, So anyway, that's just a super quick, simple example of using your voltmeter. So anyways, I wanted to redo that last video. I make these videos, and then I go back and watch them, and I go, I would not listen to that guy. He is boring. He is just dry as toast, and it bugs me to death because it's not really who I am. But again, I'll never. It's something in my head. I hate cameras. So there. I hope that was maybe a little better video, a little more worth watching than that boring guy in the last one. I'm probably going to delete that one because I hated it. I despised it. So again, there's some examples of how to use your meter. Just some explanation on voltage, the difference. This is a big one. When you're looking at a voltmeter, what is the straight line? What is the wavy line? DC voltage, AC voltage. And again, we were talking about hertz, so there's a difference in the speed of the frequency, and that's hertz. But that's something that you're never going to have to deal with. I don't deal with hertz. Everything in America is 60 hertz. Different countries like Europe, you're talking 50 hertz. So over in European countries, you're talking 50 hertz. In America, 60 hertz. It's the difference in the frequency, and that's really when you're getting into the electronics. Something that was designed for 60 hertz would not work in something that was supplying 50 hertz. Though it would be the same voltage. It'd be 110 volts, but the hertz would mess it up if the sine wave was different. So hopefully this video was less boring. Still the same amount of information, but hopefully less boring. I don't want to become that guy that puts you to sleep, because again, it bugs me to death. That's not who I am. I just hate cameras. So hopefully that is more, same level of information, and yet doesn't put you to sleep. So you guys have a good day.